Hello, welcome to the start of Unit 2, Polynomial Functions. So that's the title of our second unit that we're looking at today. Specifically today, our goal, I can successfully apply distributive law to multiplication of monomials and binomials, and I can successfully factor. So initially it looks like two major concepts are being covered here, but I want to point out that this is review. Okay, you have already done distributive law and what we call FOIL in grade 10 and 11. Similarly, the factoring is also review. So this is going to be, it's going to cover a lot of material, and then you're given 2 or 3 days to complete the associated homework. But it's still review skills. So please keep that in mind when you're looking at the amount of homework you do have the time set aside. So expanded polynomials, a review. So recall grade 9 and 10. Grade 9 is where we talked about distributive law. And our distributive law, and I'm going to go straight into examples because, like I said, you've already seen this. So examples, and it's going to be simplify. Simplify means to get rid of brackets. So the first example is just doing straight distributive law. Distributive law is when you take the first term out front. So for example, a 4x plus 2. Distributive law says to multiply every term inside the bracket by that value. So we end up with 4 times x, which is 4x, and we get the 4 times 2, which is a positive 8. So that is the distributive law. And then I'll do a second example with what we call FOIL, or some of you have been taught distributive law just extended, which is fine as well. So 3x minus 5. So the reason we still call it distributive law is because every term in this first bracket gets distributed or multiplied to the second bracket. So the x will get multiplied to the first term and the second term. The 2 gets multiplied to the first term and the second term. Now, where does the term FOIL come from? For people that aren't familiar with FOIL, you don't have to remember it. But the FOIL comes from multiplying first terms together. Then, when the x is multiplied to the 5, it's the outside terms. The 2 times 3x, those are the inside terms. And then the 2 and the 5 are the last terms. So that's where that FOIL, it's an acronym to remind students of the process. I prefer that you know it as the distributive law anyway. The FOIL is helpful in remembering it. It just works only for binomial times binomial distribution. So anyhow, that being said, multiplying the x or distributing the x in. So I have x times 3x is 3x squared. X times negative 5 is negative 5x. The 2 times the 3x, that would be a positive 6x. And 2 times negative 5 would be a negative 10. Collecting like terms, when you do this type of distribution, typically it's only the middle terms that are like. So we end up with the 3x squared, negative 5x plus 6 leaves us with positive 1x. You don't have to write that 1 in, minus 10. So there is a quick reminder or review of the distributive law and FOIL. Is there any twists or anything new this year? If you move to your next slide, I have some examples. There are a couple of extensions to this, and I'll show them to you here. So it's not really going to be too different than what you've seen already. So it could be different variables, for example. So I'll do one example with that. So 2r multiplied by r minus 5. Typically in the previous years, we only had you multiply either a number or a variable. Here we're multiplying both in. So the 2r is what's getting distributed in, and it multiplies each term. You can only multiply like terms, so technically there's a 1 in front of the r. So it'd be 2 times 1 is 2. R times r is r squared, minus 2 times negative 5 is negative 10, and r gets tagged along because we're really talking about if you have 2 r's and you get 5 more, it means we end up with 10 r's, if you want to think of it that way. Okay. Something else you're going to see as you go through the homework, you might see some multiple variable distribution. So for example, negative 3ab c squared, and we're multiplying. It could be just a trinomial. So for example, 2a minus 5bc plus 4c squared. If you're comfortable with that distributive law, it's not overly, it's not a tough extension, but this is why we went through and did exponent laws in the previous unit. You are going to have to use your exponent laws when you do this distribution. And I'll talk about it right here. So the only thing that matches up in the first one is an A and an A. They both have an exponent of 1 and 1. So that means that when we multiply, we have negative 3 times 2 is the negative 6. A times A is A squared. And the B and C squared, you can think of it, there's nothing to multiply it with, so they remain the same. In the second set of terms, now we've got a B and a C. So B and a C, so we're going to be multiplying the B and the C squared with it. So doing the number first, negative 3 times negative 5 is positive 15. Nothing to multiply the A with. B times B is B squared. C squared times C, again, that's C. Inside has an exponent of 1. Excuse me, when you're multiplying terms with the same base, exponents get added, so it's C cubed. And finally, negative 3 times positive 4 results in negative 12. The A and the B have nothing to multiply with, and now I have C squared times C squared, so we end up with C to the 4th. Okay, so we end up with that type of expansion where you're dealing with more than one variable. You might come into, and what you are going to do a little bit of for me, is you're going to have to expand and then collect multiple terms. So I'll do an example like this, because you're going to see this in the homework. And then plus 5b, and then b squared plus 4b minus 5. So there's only one extra step here. You're actually going to have to do two distributive laws, and then you're going to have to collect like terms. Remember, like terms are terms that have the exact same variable. And I'll show you that in the next step. So it's just a monomial distribution. So we end up with 12b minus 6b squared plus 21b cubed plus 5b cubed plus 20b squared minus 25b. So I said already that like terms are terms that have the exact same exponent or same variable. So for example, I'll put one underline under the b. So I'm looking for every term that has a b in it. So there are two of those. So I would collect those together. So I would do 12, take away 25. So I have negative 13 b's. Next, I'm going to look for b squareds, anything with a b squared. And that sign out front goes with the whole term. Okay? The sign out front is included with the term. So I have a b squared here, so I'll double underline it. The underlining is not necessary. It's for example purposes only here. So I have negative 6 plus 20, so that gives me plus 14b squared. And then I guess I'll triple underline any cubes. There's one there and one there. So we end up with plus 26b cubed. All right. So there is your expansion. I'll do one example with the binomial to show you the next phase or the next step involved with it. Really all that I'm going to add this year is to put a number in front. So for example, negative 3 multiplied by 2x plus 1, and then 3x minus 5, for example. So the only thing that's different that you weren't tested on in the grade 11 course was that negative 3 out front. So basically what you do is you deal with this first. You do your normal distribution, collect like terms. So the negative 3 is just going to come along. And I'm going to keep that green square bracket all the way down now that it's in blue. I'm going to go ahead and do the distribution. So that means I'm going to do either, if you're a FOIL person, it's FOIL. Or if you're just distributive law, it's distributive law. So 2x times 3x is 6x squared. Minus 2 times negative 5 is negative 10, and it's an x. Plus 1 times 3x is plus 3x. Plus 1 times negative 5 is negative 5. I'm going to collect like terms first before worrying about the square brackets. And the only like terms are the ones in the middle there. So 6x squared minus 7x minus 5. Now I'm going to get rid of the square brackets because, again, remember the instruction simplify means to remove all brackets. So I multiply the negative 3 in, and I end up with negative 18x squared plus negative 3 times negative 7 is positive 21x, and then positive 15. So there is sort of your upper end binomial expansion, and that's going to get you through the first part of the homework. And I'm going to stop the note here, and the next lesson will pick up in the next section.